Aloha, this is Roger Brewer with the Hawaii Department of Health. This is an overview of a report I recently posted to our webpage entitled Exposure Assessment, November 2021 release of JP-5 jet fuel into the Joint Base Pearl Harbor Hickam drinking water system. The main purpose of this report was to better document the specific contaminants that were in the drinking water and also the concentrations and exposure durations and such that are necessary for the medical experts to better understand health effects that were observed in the residents. When people are exposed to some contaminant in the environment, then two types of assessments are carried out. The first one is referred to as an exposure assessment, and the purpose of this assessment, and that's the purpose of the report that I prepared, was to answer the simple question of what was I exposed to. It's typically done by risk assessors. And in this case, the lead is the Hawaii Department of Health, mainly because we're more familiar with petroleum contamination in general, also more familiar with the events that happened in the field. So we're in a better place to describe exactly what the residents were exposed to and what happened. The second part of this type of assessment is called a health assessment. So once you know what they're exposed to, then how did it affect my health? And this is typically done by toxicologists and medical experts. In this case, the lead agency is the U.S. Department of Health Services. And then an agency under that, the Agency for Toxic Substances Disease Registry, ATSDR. So they're overseeing the health assessment portion of this event. First reference you see here is the report I just mentioned. This is posted to our webpage, currently dated June 2023. So these type of exposure assessments tend to be periodically updated as new information comes in. So this assessment will probably be updated again in the future. Right now, ATSDR is reviewing it. We're also waiting for some additional laboratory data we can include in the report. Second very useful reference to look at, and this is posted to EPA's webpage, is a report by the Department of Navy itself. Very detailed, almost minute by minute, definitely day by day report of the events that happened at their Red Hill bulk fuel storage facility. First on May 6, 2021, which we'll talk about in a minute, and then again another release November 20th, 2021. It's again posted to the US EPA webpage and referenced throughout the report. Some acronyms you might hear. TPH means total petroleum hydrocarbon, which in this case, I'll be talking a lot about carbon ranges, aliphatic aromatic carbon ranges. So in combination, these compounds are referred to as total petroleum hydrocarbon. These are non-specific compounds. Another set of compounds you often hear is BTEX, here NM added to the end of it. These stand for some well-studied individual compounds that are in petroleum: benzene, toluene, ethylbenzene, xylenes, naphthalene, methylnaphthalines. So we have a lot of information on this. Typically, when there's some contamination from petroleum, then we test for TPH, or basically all these individual or separate carbon ranges, lumps of hundreds of compounds together, and then these individual compounds, BTEXs. Next acronym, FSII. This is fuel system icing inhibitor. This is pre-blended into the JP-5 jet fuel at Red Hill. This is essentially its antifreeze. It's intended to keep the fuel from freezing when planes fly at high altitudes. Now you might hear some people referring this as de-icer. You're in an airport in Chicago in the wintertime or something, you might see them spraying something on the wings. That's similar to this, but this is it's a different name, different intent, might be a different mixture. So this is fuel system icing inhibitor. The main compound in the FSSI used in JP-5 at Red Hill and in general in aircraft fuel is diethylene glycol monomethyl ether. So big name, the acronym we just refer to kind of informally as DIGME, D-I-E-G-M-E, or FSSI. Laboratories are going to report this typically when they're testing samples as it's another name, same chemical, 2-methoxyethoxyethanol. The trade name, maybe it's easier just to say, is methylcarbitol. Again, pre-blended into jet fuel, stored at Red Hill. And then the last acronym, WAF, you might see this on some slides. This is a water and fuel experiment that I'll talk about that was carried out by our office, where we actually got samples from the Navy of the JP-5, put the fuel on water, and then tested the water to see what dissolved into it. The main purpose of an exposure assessment is to answer some really basic questions. And these are questions that we've been getting from the residents, and we ask ourselves about this event. So first question, how did JP-5 jet fuel get into the Joint Base Pearl Harbor Hickam drinking water system in the first place? That's kind of the setting. So we'll go over that very briefly. It's documented elsewhere. Second, what specific chemicals were in the water and at what concentrations? This is the kind of question that the medical experts are obviously asking the residents that were exposed to these chemicals. And then the third question, how long was I exposed in, or how was I exposed in for how long? Another important question, what was my exposure duration? And how did exposure change over time? In this case, went from probably lower concentrations, which still pose a health risk, to higher concentrations. Was it high enough to pose a risk to my health? Well, obviously that was. They had hundreds of people seeking medical help after being exposed to the contaminants, JP-5 contamination in the tap water at Joint Base Pearl Harbor Hickam a few weeks after the November release. But we'll look at that in more detail. And was there something else in the water prior to the November 20th, 21 release? A lot of residents were complaining of starting to get sick well before this time, earlier in the year. So we're going to look at that at the very end. It's all part of the exposure assessment. So looking at the setting, and I'm not going to spend a lot of time on this. Again, the U.S. Department of Navy, their 2022 report goes into amazing detail. I'd say on minute by minute what happened up there. On May 6, 2021, basically what happened, they're transferring fuel between two of the huge tanks that are at Red Hill. So there are 20 tanks. They all store over 10 million gallons of gasoline, of fuel each, not necessarily gasoline, about 200 feet tall, 100 feet wide. So these things are definitely huge. But May 6, 2021, during a transfer, a pipe broke. They lost 20,000 gallons of fuel. No one was there watching when it happened, but the fuel flowed down the tunnel. This is all underground, so it's like a big mine shaft. It went down the floor of the tunnel, went into a sump on the floor. It was maybe 8 feet by 8 feet or 6 feet by 6 feet or something, maybe 6 feet deep. And then it was unknowingly, the fuel was pumped automatically into a 14-inch PVC pipe that runs across the top of the tunnel. That's intended to capture and hold a firefighting wastewater if there's a big fire in the tunnel. You can see that on the bottom right-hand picture here. That pipe that the red arrow is pointing to is this firefighting wastewater pipe. So the fuel flowed into that, 20,000 gallons. It went downhill about a mile, and then at Adit 3 is where the pipe comes up out of the ground. It goes into a tank. It's as an upslope portion of it, and that's where all the fuel got trapped. It was sitting in that section of the pipe from May 6th until November 20th, 2021. So November 2021, a worker is going down the tunnel like he's been doing for days and years, and there's a valve hanging down from that same pipe. It's only about 100, 150, 200 feet from the drinking water well at the Navy, one of their wells. The trolley runs into it and cracks the pipe, and 20,000 gallons of jet fuel comes streaming out onto the floor. You can see that in the bottom right-hand photograph. The fuel runs down the floor, seeps through cracks and gaps in the floor, hits another sump further down the tunnel, goes into that sump, and then goes eventually down into the groundwater and gets sucked straight into the Red Hill Shaft drinking water well, which is one of the two main water supply wells for Joint Base Pearl Harbor Hickam. It used to supply when it was running 20% of the water. And that's how the fuel got into the system. November 25th, just listening to some of the media reports, some of the residents at the Navy base started reporting some fuel odors, and especially people started getting these odd rashes taking a shower and such in baths from the tap water. They didn't really know what it's called at first, but obviously suspected the water. By November 27th, not 7 days after release, widespread reports of fuel odors, sheens, this odd gel and foam stuff coming out of taps and garden hoses and such. Beginning with the residents closest to Red Hill facility. We'll look at a map in a minute. Basically, the residents, the homes that were closest to the well were obviously affected first, and then the contaminated water over time, the next few days, flowed out through the rest of the Navy base's drinking water system. On the 28th, 8 days after the initial release, the Red Hill shaft well was shut down, and the water being supplied then to the Navy base was from the Wyalva shaft, another well that supplied 80% of the water from initially, about 5-6 miles away and not contaminated. November 29th, the Department of Health issued a drinking water advisory to residents on the Navy base not to use the water for drinking or any other potential ways they might be getting exposed. Now, the Navy staff watching at the time, some parts of the base, the water was still perfectly fine. So there was initially an assumption it was just a small pocket of water going through the tunnel, going through the piping system, and it'll be flushed out pretty quickly. But the well pumped for 8 days after the initial release, and assuming it got into the well pretty quickly, the well pumps 5 million gallons a day, so there were actually 40 million gallons of contaminated water, up to that much, flowing through the drinking water system by that time. It's one big slug going through the system. So in the subsequent weeks and months, then residents still using the water when the contamination started to hit their neighborhoods began seeking medical help. And that actually occurred pretty soon after, by the 29th, this is already happening. Then ATSDR starts to get involved, and the water was still being used by residents. People were still getting sick in areas where they were initially told the water is still safe to drink up to several weeks after the initial release. In the bottom here, then we have several photographs of the contaminated water. And one thing that stuck out looking at some of the media reports, and first off, kudos to the media for documenting what happened here. They're the only ones that did. I haven't seen any other videos or photographs documenting contamination of the water itself, but you can see here cups with sheens and foam, and there's some yellow ice in the middle. We'll look at some of the pictures of the water catching on fire and this foamy stuff and jelly stuff coming out of garden hoses. But again, thanks again to the media and especially to Hawaii News Now. We'll look at some clips from their videos in a minute. So that's what happened, and then essentially the whole base was affected with the heavy contamination. I think it flowed through pretty much all of the base. Here on the left-hand figure, this is a GIS map. You see the Navy base, and all the spots there are where they were getting calls by November 27th and on about odors and sheens and stuff in the water. And you see the bright yellow is in the Salt Lake in that area. They were especially hard hit. Right above that, you see all the red spots. This is Aliamanu Military Reservation, the Red Hill community. They're the ones that were closest to the shaft. So they're the ones that got hit first. And then over time, the contaminated water made its way throughout the base and affected other residents. On the right-hand figure here, this is a map, all the green areas, individual neighborhoods for the Navy base. The X's represent field logs by Navy staff where they were documenting fuel odors and such in people's taps. Sheens and jet fuel floating on their toilets and such. So you see it pretty much covers the whole base. The red circles filled in are residents I've talked to personally that said, yes, we had sheens in our water also in that area. And then the triangles there are just where there were no documented reports, at least that I found. I'm sure it's probably documented somewhere, but they were obviously heavily contaminated also. So the main point here is the whole base was affected. The Navy flushed the drinking water system, started, pretty much immediately as soon as they shut the Red Hill shaft down. There's still 20 million gallons a day coming into the drinking water system. So they flushed it for about 100 days. Residents were told eventually not to use the water, at least even if they weren't told, they quit using the water. 10,000 residents moved off base into temporary housing and hotels and such until the system could be flushed and cleared. So 20 million gallons a day for about 100 days, around 2 billion gallons of water were flushed through the system. The drinking water system was declared safe for use again in March 2021. So you're looking at 3 or 4 months after the initial release. The exposure assessment, again, there's some very basic questions that you ask. We just went over how did the fuel get into the drinking water system to begin with. So now I want to look at, especially it's what I was focused on, what were the specific chemicals in the contaminated water, what were the concentrations, how long were people exposed, how were they exposed, how did it change over time. Just document, was it high enough to pose a health risk? Obviously it was, but we'll get more details on that, and was something else in the water before the November release. Let's look at exposure duration first, and this is something important for the medical experts to understand. Of course, they already know this. We're just documenting it here. This is a summary of ATSDR's guidance. So when you look at health effects, then one thing you look at is how long people were exposed before they were affected by these contaminants. They break it into 3 different categories: acute, subchronic, and chronic toxic effects. So acute toxic effects means that you start to have health effects within a few minutes to up to 2 weeks after exposure. This typically means there's short-term exposure to very high doses of contaminants. You're getting sick right away. Chronic effects at the bottom, kind of the opposite, where there's very low concentrations in the water, but over many years they start to pose health effects. This is where cancer effects and other effects to your alimentary tract and such start to occur only after several years of exposure to very low concentrations. That's what most screening levels we publish are based on. We assume low concentration exposure over many, many years. Then subchronic falls in between. So health effects are starting to be observed within a few days or a few weeks after a continuous exposure. So the exposure at Pearl Harbor was pretty obviously, when you were just focusing on the November 20th release, people were having health effects within days, or probably in some cases minutes or a few hours. So we're looking at acute to subchronic toxic effects. That's important to understand because we have some acute toxicity factors for inhalation. So we can actually take these toxicity factors and come up with screening levels, what concentration of JP-5 aliphatic compounds in air would pose potential short-term health effects, subchronic health effects. We can put a concentration on that and relate it to what people's health effects were. Same thing for exposure via ingestion and dermal contact using subchronic toxicity factors. We can put a number on a concentration that was probably in the water that was causing health effects. It was above this concentration. We'll look at it in a minute. That's exposure durations. The next thing we look at in the exposure assessment report is how people were exposed, just to document it, kind of methodically go through what happened and how people were exposed. So first, looking at inhalation, the first exposure of residents and workers in the area occurred through impacts to outdoor air. This was due to venting of the Red Hill facility itself. So this facility, again, is underground. There's, I think, 3 miles total of tunnels. They have these huge fans that suck air out of the tunnels and blow it to the outside and bring in fresh air into the tunnels. So when the fuel was first released, all the vapors were getting sucked into the ventilation vents and getting discharged to outdoor air. And that's what some of the workers coming in immediately after the release, coming down H3, one person reported they could smell jet fuel vapors coming down H3 Highway, which is just to the northwest of Red Hill. One thing that happened is when Aliyah Manu Military Reservation here in the left-hand figure, it's a neighborhood residential area that sits in a volcanic crater. So it has pretty poor air circulation. They're sitting in a bowl. They're directly downwind of the Red Hill facility when the trade winds are blowing. The trade winds are blowing. I checked the weather reports continuously for the several weeks after the release. So basically the vapors getting vented out of Red Hill were coming straight into Aliyah Manu Military Reservation and just getting trapped within there. And that's what the people were smelling and being exposed to the vapors initially. Another way they're exposed to the vapors in outdoor air was when the Navy was initially started flushing the fire hydrants in the neighborhoods, trying to flush out where they were kind of optimistically hoping was a small amount of contamination in the wells or in the drinking water system. So untreated water, this water had a lot of sheens, heavy contamination in it, contaminated the soil and such. And there were a lot of vapors coming off of this initially. Eventually, they put carbon filters on the hydrants before they did the flushing. But for a couple of weeks, I think initially after the release, they were doing this. The vapors were coming out, at least for several days at a time. The other inhalation pathway was in indoor air. So the residents were initially told, again, I think it was November 29th, optimistically hoping there was a small volume of contaminated water in the drinking water system. They were asked to flush their taps and their showers for 10 to 20 minutes. Well, that would have been fine if the stuff wasn't volatile. Maybe that would have worked, but this jet fuel is highly volatile. So a lot of houses immediately filled up with very high concentrations of jet fuel vapors, with people getting acutely sick, vomiting and such. And we can tell just by the health effects how high the concentrations were there of jet fuel vapors. That's discussed in the report. EPA publishes something called acute exposure general levels. So when we know people were starting to vomit and such and get quickly sick, we can we can put a concentration on what had to be in the air at that time inside their house. And one interesting thing in the EPA's report, you can review it yourself, is once you get about 5 times over this level that causes people to start becoming acutely sick, then you can start hitting levels in indoor air that could cause some type of permanent health effects. And a lot of the residents are complaining of long-term lingering health effects. They weren't transient initially. Some people, medical experts, thought they might be. So that's something for the health assessors to look at ATSDR. Other exposures to indoor air, too, during bathing, especially when lower level contamination was coming in, your kids were bathing in the water, and there could have been some vapors coming out. There probably were, but low levels, but it could have been high enough to cause some concerns. And then other ways of vapors getting into air during washing of clothes and dishwashers and such. So that's the inhalation pathway of exposure. Other ways residents were exposed were through ingestion of tap water and dermal exposure, getting back to the showering and such again. First, looking at ingestion in the tap water, drinking contaminated tap water is an obvious route of exposure. But also, I would think, especially when the heavier contamination hit, because there's a question, all the risk assessors I've talked to, we've looked at petroleum for years. Of course, we didn't really have an event to compare it to, but how could people have been exposed to such heavy contamination causing such quick health effects and not know it? My guess is some of it also occurred during cooking, when the heavy contamination, the water with sheens and emulsions coming through. It was in the food, the soups and such are being cooked, but you couldn't really tell it. It was masked by the food and spices and such. So that was ingestion exposure. Dermal exposure, again, in baths, we heard of a lot of young children especially were taking 30-minute baths or something and coming out with rashes all over their bodies. So that's a dermal absorption pathway. And also in just bathing and showering and such, same thing, dermal absorption, but also getting more potential exposure from vapors in the well during showering. So those are the main exposure pathways: inhalation, ingestion, dermal absorption, just documenting that, how the contaminants actually got into the people. One interesting thing, again, looking at some of the media reports and their films and videos, there are three very obvious different categories of tap water contamination, different levels. The first is just dissolved contamination. You're not seeing any sheens or anything, but maybe you suspect something is in the water. So the dissolved JP-5 jet fuel is in the water. It's probably the first water that went through the system before the free product, the product of jet fuel in Red Hill Shaft got sucked into the drinking water system. And then the second type category of contamination, you see videos with the dissolved sheen, there's dissolved contamination plus a sheen on top of the water. We'll look at that again in a minute. And then the third category, which is the more serious contamination, is dissolved. There's a sheen, there's some fuel product in the water, plus there's this odd emulsion. So let's take a look at these three categories in more detail. These are all clips of videos from especially Hawaii News Now, and also some from Vice News, but videos where they went to the residences and were actually filming what the water looked like at the different residences, talking to them. So again, this was just a huge help, and they're the main ones that documented the contamination. So let's take a look at this. I've got just a few second clips of each one. First one, the upper top, petroleum sheen. This is what petroleum contamination looks like in water. It makes a peacock sheen on the water. And this, when I first heard of this is what I would expect it to have seen in all of the water. It's very typical. We see this in the field all the time. It releases to lakes and rivers and oceans and such. So that was easy enough to look at. But then look at this second one. The second video here on the upper right. Look at all these little particles in the water. That's not typical petroleum contamination at all. So what is that stuff? Well, it's some type of emulsion in the water. And based on some of the documents we reviewed and talking to fuel experts, there's a very strong chance that this was an emulsion made up of the icing inhibitor, this DIGME, diethylene glycol. And also there's going to be some fuel and water mixed in it. But that's what happens, we've been told, and now we're seeing, when the fuel hits the water, which I predicted totally wrong in the February 2023 memo we published, that all this icing inhibitor should dissolve into the water immediately. That's not at all what happened. It stayed with the fuel, it formed this emulsion. We'll look at that again in more detail. Now the bottom left-hand corner, look at this foam on the water coming out of someone's tap. This was coming out of garden hoses and stuff too. Again, not at all typical of just only petroleum contamination. There's some kind of emulsion in the water. So what was this? Was it more of this icing inhibitor emulsion is just some of the simple green that was used by the Navy to clean up the release in November in the tunnel. They probably used quite a bit of water. This water would have flowed down through those same gaps in the floor and the sump into the groundwater and got sucked into the Red Hill shaft. So some of this foam, it could be a surfactant they used in cleaning. It could be the emulsion. My guess is it's probably a mix of both. And again, this water reeked of jet fuel in this cup, so it also has the jet fuel in it. And then the bottom right-hand corner, this is the interesting one here. Watch the flame. Keep watching. Boom, right there. Something goes through. You see that flare up. That was do one more time. That was either the jet fuel itself, or it could have been the icing inhibitor. Concentrated icing inhibitor. It's an ether, so it's also highly flammable. So this really helps document what was in the water. And again, it wasn't just the hydrocarbons, it wasn't just the sheen. There are three very different, distinct categories of contamination. So we have to understand each category. What were the chemicals? What were the concentrations? And that's what I focused on. One more time with the flame. I'll watch that if it wants to. So what were the specific contaminants now in these three different categories? Exposure versus the exposure pathway. So we talked about it, ingestion, dermal, inhalation, exposure pathway. Dissolved phase contaminants, that's easy to predict just based on the fuel composition. We know what was in it. So even without getting samples, we know that dissolved in the water would have been mostly the aromatic compounds, these rings of carbon. So benzene is one type of aromatic compound, the BTEX, but there are lots of others that actually made up the main component of the jet fuel. That's what was dissolved in the water. There might have been some of this icing inhibitor, this DIGME. If you look at the solubility, it's totally miscible in water. It should have been high concentrations. It wasn't. But there could have been some dissolved there they were exposed to. But then in the dissolved phase, let's add in the sheen and this emulsion. When the sheen, you're going to get the pure fuel, which we'll look at in a minute. It's mostly these aliphatic hydrocarbon compounds, these long strings of carbon with hydrogen attached to them. There's still a fair amount of aromatics compounds in the fuel itself, and that would have been in the sheen, what they're being exposed to. For inhalation, when you have a sheen, the main concern is these aliphatic compounds are highly volatile. They don't like water. And again, when you start getting these emulsions in there, you're going to get a lot of this icing inhibitor in the water. So we can predict what was in the water. We can guesstimate what the concentrations were, but we really need sample data. And that was one lapse in the response to this is the agencies involved were understandably focusing on flushing all the lines. Let's get all this contamination out. And the sampling, the detailed sampling really focused on documenting that the water was no longer contaminated. So all the early samples that were collected around the Navy base, they were only tested for total organic carbon as a screening method. And this just tells you how much carbon is in the water. There shouldn't be much. There's always going to be some trace carbon from algae and stuff. But when you saw high levels of total organic carbon, you'd be pretty sure that was the fuel. The thing is with this test, you can get it back immediately within 24 hours. With the detailed test, testing for petroleum contaminants can take up to 2 weeks. So that's one reason why there's no data documenting contaminant levels at the levels that residents were exposed to. It's because they were only testing for organic carbon. If there is any data, we haven't seen it. And one problem with this organic carbon data, good idea, turned out to be totally unreliable for various reasons, but some samples that were obviously heavily contaminated jet fuel came back non-detect for total organic carbon. That's because the detection level was too high and there were just other problems method running it. So we have no data for a contamination drinking water system. Some great videos, no sample data. It's not necessarily a problem. There's some good alternatives. We got some fuel. The Navy gave us some JP-5 jet fuel from the Red Hill facility, and we'll look at this in a minute. We gave it to a laboratory, had them put a layer of the fuel on water, and then we tested the water over several weeks to see what dissolved into it. So that's as good as you can get with understanding what went through the drinking water system. They also tested the fuel, so now we know what the sheen would have looked like, the specific chemicals. We also have data from the Red Hill shaft when they turned the well off. We have sample data there showing what the water looked like at the time they turned the well off, which is indicative of the heavier contamination that went through the system. Then just field observations, sheens, odors, even health effects give us some idea of concentrations in the air and the water and such. These are the fuel experiments, and we discussed this in more detail in the report. I'm not going to go into a lot of detail, but basically what happened, we sent fuel to this laboratory. It was Newfield's laboratory. Alpha Laboratory, both in Massachusetts. They're some of the top experts in petroleum in the U.S., probably in the world. And what they did, the chemists there, they set up 5 funnel flasks. You see in the left-hand picture here. And each one of these flasks, they put in a liter of water, and then they put a layer of jet fuel on top of it, the JP-5, 10 milliliters. So about a 1 to 100 ratio of water to fuel. And they let it sit for 20 days, and they tested the water, on the first day after a few hours, and then went to the second flask at day 5 and took a sample of the water to day 5 to see what was dissolving into it. Then on days 10, 15, and 20, the same thing. They took a sample out of each one of those respective flasks there, test the water, and they can see what's dissolving out of the fuel into the water. So we get a real good handle on what was in the dissolved water going through the drinking water system. Some of the experiments too, we know they use simple green, like I said before. We had the laboratory spray simple green on top of the fuel in a second set of experiments and see if that affected the solubility and dissolution of this stuff. And it really didn't make any difference in the well. And that simple green actually is pretty diluted by the time you use it. It's just a soap. So that's what we did, and each one of the water samples collected were tested for this BTEX, these individual compounds, BTEX, naphthalene, methanaphthalene. Also, importantly, they were tested for the aliphatic and aromatic carbon range compounds, all this other stuff that makes up the main component of jet fuel. Along with the icing inhibitor, the DIGME, they also tested samples for butoxypropanol, and the samples where simple green was used. So the data then reflect the dissolution of JP-5 into water over time, over a few weeks, pretty similar to what we can expect would have happened up at Red Hill. Also, they collected vapor samples over the fuel on 2 different times, on day 0 with fresh fuel, day 20 with the fuels getting a little old. So we know what the vapors were made of, the exact compounds, the BTEX, where they're mostly the aliphatic compounds in the fuel. So this is the results of the laboratory experiments. Again, not going to go to that in detail. Left-hand pie chart here, this is what the fuel is made of. It's 98.6% all these aliphatic and aromatic carbon range compounds, hundreds of compounds just lumped together under what we would refer to as total TPH, total petroleum hydrocarbon. That makes up most of the fuel. And most of this were the C8 to C18 aliphatic compounds. They're some of the more toxic compounds in petroleum. They made up, I think, 80% or close to it of the fuel. The rest was mostly these greater than C8 aromatic compounds. That just means there's 8 carbon molecules in the compound. And then very little BTEX, almost no benzene. There's no benzene in JP-5 fuel, almost no BTEX. It's a good reason why you can't just look at BTEX when you look at petroleum compound to assess risk. In this case, there was no benzene. If you only looked at benzene, you're going to say there's no risk, but there's all this other stuff in there. And then there was a small amount of the DIGME, the icing inhibitor. We measured 0.05%. It's probably twice that much in the fuel itself. Navy has very specific requirements for icing inhibitor and jet fuel up to 0.11%. So about 1,100 part per million was probably the true concentration of icing inhibitor in the fuel itself. So that was the fuel. Now we know what compounds were in the fuel. This is what was in the sheens. What was dissolved in the water? Well, there wasn't a whole lot of BTEX and such in the water, in the fuel to begin with, but that stuff went straight into the water, from the fuel into the water because it's highly soluble. That made up about 40% of the contaminants in the water under the fuel. But most of the contaminants dissolved into the fuel were these greater than C8 or aromatic compounds, or more than 8 carbon compound aromatic compounds. They're the main component in the fuel, and they actually pose the highest health risk. And very little DIGME, very little of the icing inhibitor went into the fuel, into the water. And I was totally wrong in the February memo I posted earlier this year. Instead, this icing inhibitor, when the fuel hits the water, and these fuel experts told us this would happen, and this is what we saw in the laboratory experiments, it forms this gel. So you get a concentrated icing inhibitor with hydrocarbons, the fuel, in this jelly-like material that forms on top of the water. And there's this 2002 document referenced in the exposure report that goes into this in detail. It's a big problem for pilots because if you don't balance the icing inhibitor and the fuel properly, you'll get this jelly forming in the fuel and it plugs up your engines, and that's not good at all, obviously, when you're flying at 30,000 feet. So that was what was dissolved into the water, a little bit of DIGME, a little bit of icing inhibitor, mostly these greater than C8 aromatic compounds, and then some of the BTECs. So now we know what was dissolved, and we know what was in the fuel and in the sheens. And a very trace amount of the simple grain. That really didn't seem to play much of a role. At least it was very low concentrations in the water. Most of it was, if it was there, it was probably staying in this jelly that formed. So the next thing, we know what compounds were there. Next thing we need to do is what were the concentrations of these compounds that people were exposed to. So the term for this is called reasonable maximum exposure concentration, RME concentration. So we need to do that. We do that in the report for each of the 3 different categories of contaminated tap water: dissolved phase, dissolved plus sheen, and we're adding the emulsion. So we know the compounds, what were the concentrations that were likely causing the health effects. So it looks like detailed. It's not that detailed to do, actually. It's technically, but so for the dissolved phase contaminant levels, we just look at the fuel water study data. We have data for what dissolved in the water in these studies we showed. We can apply that directly to the first category of contamination and get a good estimate of what was in the water at the point it was still the initial contamination, lower levels, only dissolved. We'll look at that in a minute. Still high enough to pose health concerns, obviously. For the second category, dissolved plus sheen, where at the Red Hill shaft itself, water samples there showed 150 milligrams per liter of total petroleum hydrocarbons, TPH. These are all the carbon range, aliphatics, aromatics, everything all together. That gives us an idea of the concentration of the total hydrocarbons when there's a sheen on the water. That seems pretty reasonable. That's about, it's about 5 or 6 drops or so of jet fuel, in that range in a liter of water. That's enough to cause a good sheen. So now we know what we can get an estimate of concentration for dissolved, and especially with the sheen in it. When you add in the emulsion, looking at some of the media reports and their videos, I used to have to do this in my geology classes. That's quite a bit. Estimate the concentration of something based on just visually the amount of particulates or particulate matter in it. So, it's not that conservative an estimate even. 0.01% emulsion in the tap water for this type of contamination is pretty reasonable, I think. And some of the military reports, when they're looking at this apple gel, they suggest that this stuff could be 40% icing inhibitor, or this digby diethylene glycol. So if we have 0.01% of this stuff in the emulsified water at 40% icing inhibitor, we can actually put a concentration on the icing inhibitor in that third glass of water up there, or where we see the emulsion. That's what we did in this slide here. Again, you see lots of numbers now in the report. 3 different categories of groundwater contamination: dissolved, dissolved plus sheen, dissolved plus sheen plus emulsion. So on these columns, you see here's the main contaminants in the jet fuel, then the icing inhibitor, digby additive. So these are the estimated concentrations, reasonable maximum exposure concentrations that were in the water that the residents were exposed to, depending on at what type of contaminant category was in their tap water at the specific time they were exposed. So probably all people were exposed to something similar at different times. So we can put a number on it. So the total concentration of hydrocarbons in the, say, dissolved 5.2 part per million, 5,200 micrograms per liter, part per billion. That's right on what we predicted before we even got the data. Add in the sheen, and now the concentration of total hydrocarbons goes way up, way up, 150 part per million, which is what we saw in the Red Hill shaft well. That's probably what reasonable estimate of the concentrations of people who are exposed to tap water with a sheen on it. And you can see the different contaminants. Your BTEX levels, individual compounds, don't go up that much when you add in a sheen. That's because most of what's in the fuel itself that's creating that sheen are these aliphatics, C8 to C18 aliphatic compounds. The concentration pretty much 0 dissolved, but when you have a sheen on the water, you're up to 121,000 micrograms per liter. That's what's causing the health effects. And then still your aromatic compounds, which they dissolved in the initial category, but they're a lot higher also when you have a sheen. Then the third category, add in the emulsion. So the sheen, the dissolved stays pretty much the same, but then your digby, your icing inhibitor concentration could be really high, up to about 400 part per million or 400,000 micrograms per liter, we would estimate, if you have these pockets of icing inhibitor concentrated emulsions coming out in your tap water, which certainly seems to be what was happening based on the videos we see and the health effects. So that's what was in the water. We know the contaminants, we have our categories, we know the concentrations. Here we're comparing it now, the concentrations, reasonable maximum exposure concentrations estimated in the water to subchronic screening levels, which you see here on the left. And the report goes into detail how we calculate these. It's pretty simple. There's toxicity factors for the BTEX and naphthalene, methyl-naphthalenes and such. It's including the TPH, the carbon ranges, aliphatic aromatics. So based on these toxicity factors, we can calculate a screening level that tells us a level above which, if you're exposed to this concentration, if you're exposed to contaminants above this concentration for more than a few days or a few weeks, you're probably going to start expressing some type of health effects. So if you look at the different types of contaminants categories now, the dissolved phase contaminants, what was the main contaminant of concern? You see it's red, the TPH. These are the dissolved greater than C8 aromatic compounds. So they're over an order of magnitude above the concentration at 350 micrograms per liter, which that's above that level you'd expect some health effects. So that's what's driving risk in the first dissolved phase contaminants. Some contribution from 2-methyl-naphthalene, you see the 250 is highlighted in yellow. I neglected to highlight the naphthalene in yellow, the N. That's well above the subchronic screening level, so that could have also been posing some health effects, even though it's just dissolved. This is before the sheens hit the heavy contamination. So now the groundwater, the water coming through the system, it's more heavily contaminated. You're starting to get a sheen in your tap water. What's the main contaminants of concern? It's the same ones, but now they're at much higher concentrations, especially the TPH. You have all these C8 and higher aliphatic compounds creating that sheen. Now you're up to 150,000 micrograms per liter. And that compare that to the action level for TPH with a sheen, that's a 270 micrograms per liter in the parentheses there. So you're way above it. You're almost 1,000 times above it. So not surprisingly, people are exposed to the tap water with a sheen on it are going to get sick pretty quickly. And they're getting sick mainly from these C8 and higher aliphatic compounds. And that's something the medical experts would need to know, the health people doing the health assessment. There's also some, could be significant contribution coming from naphthalene and this 2-methyl-naphthalene. You could have moderate to high risk health, even after just a few days or a few weeks exposure to this with the sheen. And even shorter, the concentrations could have been higher than this. The screening levels could be, for acute, could be close to it. Effects within a few minutes or a few days. Then the last category, add in the emulsion. So now you see the same problems, the same high risk drivers, we call them, but now the DIGMI, the icing inhibitor, which could be up to, we estimate 400,000 micrograms per liter. There's different ways to calculate that, but the main point is that subchronic screening level is 800 parts per billion, and you could be up to hundreds or even 1,000 times higher than that. So if that's the case, and not unexpected, anyone exposed to this can be suffering health effects very quickly. So this seems to match up pretty well with what we're seeing in the health assessments in the field, and this is what we'll provide to ATSDR to better assess the health effects in their health effects assessment. So there's a lot of numbers in that. I tried to simplify it in this figure here. The risk drivers for contaminated air and water. So when dissolved phase only, you can't see sheens in the bath water and such, in the tap water, but you're probably inhaling some of these greater than C8 aromatic compounds, or greater than 8 carbon molecules in these compounds. Be one of the risk drivers. For ingestion, dermal absorption is such a main risk driver again of these aromatic compounds, greater than C8 aromatics, with some contribution from naphthalene and methyl-naphthalenes, but the main risk is these other aromatic compounds in the water that dissolve from the jet fuel into the water. Start getting a sheen, again, just repeating from the last slide. Inhalation, when you have a sheen or free product, what's coming out of the vents at Red Hill Shaft is mostly these C8 to 18 aliphatic compounds, well above any levels that we'd be concerned about for potential health effects. And then the sheens in the water at the residents, when they're flushing the taps or taking showers and such. Again, the main contaminants of concern, these C8, C18 aliphatics. And still an issue, a little bit lesser an issue, but still very high risk, the C8 aromatic compounds, for ingestion, dermal absorption, and then plus contribution from naphthalene, methyl-naphthalenes. And then the last column there, again, just repeating, the emulsions come through. If we're right that that's where the icing inhibitor. We know there was icing inhibitor in the fuel. We know the fuel went through the system, so obviously people weren't being exposed to it. It's probably mainly in these emulsions, but the DIGME, the ethylene glycol monomethyl ether, would be posing a big health risk. That's just a summary of it. So we have a good idea. It's not like we don't know what people were exposed to. Yeah, we do know. We just had to go through it methodically and write it down. So that's something important to understand. And then the last question that came up in the exposure assessment was, there something else in the water prior to the November 20th, 21 release? So for that, what we have to do is go back to Red Hill itself and see what was going into what was in the groundwater under the Red Hill tanks, and also what was being fed into the drinking water system, because at that time they weren't doing detailed sampling for hydrocarbons in the drinking water. So here, these are two chromatograms. These are in the exposure assessment report in the attachment. A chromatogram is it's what laboratories use when they test water samples or any kind of samples. They essentially concentrate the contaminants and they start to slowly heat it up, and they watch to see what comes off at different temperatures. And based on the temperature, they see some vapors coming off. They can know pretty reasonably what compound it was. That's what you see here in the left-hand figure. It's called a chromatogram. From left to right across these chromatograms, it's getting to be higher temperature, which means you're boiling off these compounds at higher temperatures. And this hump is what petroleum contamination looks like. In this case, this hump is sitting in we call it mid-range organic compounds, a kind of semi-volatile compounds. It matches up real well with JP-5, jet fuel. This is from a groundwater sample collected under Red Hill facility, monitoring well number 2, right under the tanks, July 15, 2021. So we know this contamination has been there for years. That hump's always been there. That's the hydrocarbons. But look out into high range organic range, the higher boiling compounds, really not volatile compounds at all typically. You have to really heat the sample up. Then in these circles, the 3 red circles there, these compounds pop up, and they're not hydrocarbons. Every fuel chemist I've talked to said those were not hydrocarbons. It's something else in the fuel. Maybe it was degraded fuel, possibly, but even that, most of them think it's something else. But they're detected in the groundwater under Red Hill. They started to show up sometime in late June. They were there in July, and they were persistent in the groundwater all the way through November. Then they started to fade away right before the big release. So what is this stuff? Well, it could be something related to the May 6, 2021 release. Maybe the fuel flushed some older, heavier fuel out of that had been sitting on the tanks for decades into the groundwater. Maybe that was it. Maybe it was some surfactants used in cleanup. Maybe it was just, this stuff is candy for bacteria in the water. Maybe it was just algae, growing in the water that is showing up in the test. We don't really know. The Navy could have carried out more detailed tests to see what these specific compounds were, but by the time they got the data and somebody looked at it, it was too late. The samples were too outdated, I assume. At least we've never seen any data. But here's something. That was what's under the groundwater, but look at what was going into the drinking water system itself. This is on the right. It's another chromatogram. This is a sample collected from the Red Hill shaft faucet. So this is the pipe from the well that feeds into the drinking water system. Same day, July 15, 2021. You see the mid-range organics. You see all these spikes there? That's probably stuff that the laboratory puts in the water just so they can see where they are. They know specific compounds in the chromatogram and temperatures. That's not really petroleum contamination. It's just stuff they put in when they're doing the analysis. But look over to the far right in high-range organics. There are those 3 humps, the same signature again. So it was in the groundwater under the tanks. It's in the groundwater that's being pumped into the drinking water system. Now you could say, well, maybe there's some contamination at the laboratory, but the laboratory tested blank samples, clean water, and this didn't show up in there. Maybe it was some contamination in the equipment they were using to collect the samples, where they also tested equipment blanks, and it doesn't show up in that, where they just pour clean water over the sampling equipment. So pretty definitely this was something that was in the water. At the concentrations, a few hundreds of parts per billion, it could have been higher, it could have been lower. We're not really sure because we don't know the exact compounds. So that was what was in the water before in June, July, August, September, at least during that time period, faded away in November before the big release hit. We don't know what they were, and this is something ATSDR folks are going to look at in more detail with some of their experts. That's also discussed in the report. Was these causing health effects or not? I can't say myself. I'm not a toxicologist, medical expert. We're just showing what was there as part of the exposure assessment. So in summary, for this exposure assessment, and what we've done is that the health effects associated with the November 20th release, at least of JP-5 in the drinking water system, occur within a matter of minutes to weeks. So this is all acute to subchronic toxicity, something important for the medical experts to understand. Most of them, I'm sure, know this by now. Most areas of the base were affected. So you may have started off with lower level concentrations just dissolved, but eventually it looks like the sheens, the heavy contamination made it through most areas of the base over the next few days or weeks. Exposure occurred via inhalation of JP-5 vapors in indoor and outdoor air, and also via ingestion and dermal absorption, drinking, cooking, bathing with contaminated water. So the type and magnitude of water contamination, again, varied spatially and over time within the base. So this pockets of heavily contaminated water are probably moving through the drinking water pipes under the streets. If you happen to be in your house and turn on your tap or your shower at the time a heavily contaminated water is passing through the front of your house, it's going to get sucked into your house. Maybe your neighbor comes home later in the day where that really heavily contaminated groundwater has already moved down the system. Now the water is less contaminated or maybe even clean. Then when they turn on their taps, they don't see anything. They're wondering, gee, that's odd. What's wrong with my neighbors? Thinking it was heavily contaminated. So it caused a lot of confusion, but that's probably what was going on during the drinking water system in the days and weeks subsequent to the November release. There's a range of concentrations of the specific chemicals and exposure and health effects. We can reasonably predict that. So I want to get away from this idea I've heard of we don't know what was in the water going through the system and what you might have been exposed to. We can make a very good scientific estimation of that. Good, well supported. The health assessment, no kidding, I have to say, supports elevated health risk associated with inhalation of aromatic and especially aliphatic compounds, the fuel and ingestion and dermal absorption of these compounds, contaminants. If we just looked at the data and not known anything about health effects, and then we're told people were drinking this or being exposed to it for several days and weeks, we would have known right away just by looking at the data, wow, those people must have gotten really sick. So, it's no surprise to either party, but this document just supports that. Then HIDOH, our office has asked ATSDR to review some of the updated toxicity factors for the carbon ranges. We had our action level we developed immediately after release, and they applied when they were screening it to clean up the system, was 266 micrograms per liter total petroleum hydrocarbons, TPH. That was based pretty simply on earlier US EPA toxicity factors for these carbon ranges and aliphatic compounds. It's not that complicated to come up with. But since then, we found out in 2022, EPA has updated those toxicity factors, and now they're 3 times more stringent. So you would essentially divide our action level we've been using, still are using, by a factor of 3. We've asked ATSDR to review these updates and get their opinion on the new toxicity factors and if they're applicable to JP-5. This is going to take some time. They're working through all the health effects, trying to understand that better. They're going to go through the data in more detail, especially in the groundwater. And then the last point, again, there's some undetermined contaminant was present in the groundwater drawn into the drinking water system between at least July 2021 to November 2021. Again, that's something else that ATSDR is going to look at in more detail. So that was it, kind of a lengthy overview, but I hope this helps understand the motivations, the purpose behind exposure assessment. And then there'll be some time tags in this presentation. We go to specific points, and this should help fill an information gap for the medical experts looking at the health effects, and also hopefully for the residents themselves. So thank you, and my email address is on the first title page, always open to questions. Thanks.